Okay, so now we're going to introduce an extension of the Gauss method, and this is called the Jordan-Gauss method. And it's an extension that has some advantages. So let's use this example, and we're going to use our row reduction techniques, and we're going to keep going and watch what happens. Okay, so I'm going to put it in a matrix form so we can see it easily. So we got 1, 1, negative 2, negative 2. And then we got, going down, we got 1, 0, 1. And so then we got 0, 1, 3, 7, 0, 1, 3, 7. And then we got 1, 0, negative 1, negative 1, 1, 0, negative 1, negative 1. Okay, so now what we're going to do is we're going to reduce this. Okay, so I'm going to take negative row 1 plus row 3. And so what that's going to do is that's going to give me what? It's going to give me 1, 1, negative 2, negative 2, 0, 1, 3, 7, and then it's going to give me 0, and then negative 1, and then 1, and then 1. Right? So all I did was the first step. Okay, so now let's do it again. Now what I'm going to do is I'm going to take row 1 plus row 2. Or it should be row 2 plus row 3, I mean. Row 2 plus row 3. That's going to give me, again, I'm just going to copy these over. 1, 1, negative 2, negative 2, 0, 1, 3, 7. And now what I'm going to do is I'm going to add these rows. So this is going to give me 0, 0. And then this is going to give me 4. And this is going to give me 8. Okay. Now what I'm going to do is I'm going to, this is normally where we would stop, right? In the Jordan-Gauss method, this is where we'd stop. We're going to keep going. I'm going to multiply the bottom row by 1/4. Okay, I'm just going to do a scalar multiple. So I'm going to do 1/4 times row 3. So now I'm going to come up here and I'm going to continue. So if I do that, now my matrix becomes this. It's going to be 1, 1, negative 2, negative 2, 0, 1, 3, 7, 0, 0, 1, 2. Okay? So now I'm going to keep going. In fact, I'm going to, see, now I have a diagonal of 1s, and now I'm just going to keep going. Now I'm going to get rid of these numbers over here. So I've got this triangle of zeros here. I'm going to get a triangle of zeros here. So the first thing I'm going to do is I'm going to take negative 1 times row 2 plus row 1. Okay, see what that does. So I'm going to do negative row 2 plus row 1. And so now what happens to row 1? Well, that's going to be 1, 0, negative 5, negative 9. And of course, the next two rows are just going to be unchanged. So 0, 1, 3, 7, 0, 0, 1, 2. Okay, now let's keep going. Now I'm going to use this to eliminate these two and make those 0. So how am I going to do that? I'm going to take negative 3 times row 3 plus row 2, and I'm going to do 5 times row 3 plus row 1. And so that's going to give me what? The bottom row is going to remain the same, so 0, 0, oops. 0, 0, 1, 2. The next row above that is going to be 0, 1, 0. And what happens here? Negative 3. So negative 3 times 2 is negative 6 plus 7 is 1. And then I'm going to do 5 times row 3. So 5 times row 3 plus row 1, that's going to give me what? That's going to give me 1, 0, 0. And then 5, so 10 minus 9 is 1. And now look at what I have. I have this matrix, and I can't reduce it any further. And I can easily solve this because what does this tell me with the diagonal ones? That's telling me what? X is equal to 1. Y is equal to 1. Z is equal to 2. Oops. And we're done. Now, using one entry to clear out the rest of these, so when I used the 1 here to clear out these two to make them 0, or when I used this one to make that 0, that's called pivoting. Okay, so that's going to be a term we're going to use from now on, is we're going to be pivoting on certain entries. And the purpose of pivoting is to eliminate other numbers in the row. Okay. Now notice that the row combination operations in the first stage move left to right, while the combination operations in the third stage move right to left. But that's, well, in the textbook that's the way they did it. But notice how I did it, just moving left to right. Okay? You start with the first row, you want to get this to be a 1, eliminate everything underneath it. Then you want to get to the second one, you want to use this as your pivot to eliminate the ones on top and the bottom. And then you use the next one to eliminate these two, and then you're done. Okay? And so once you get your matrix where on the left side, the coefficient matrix has just a diagonal of 1s and everything else is 0. And the right side, is just the constants, whatever they are. Your matrix is solved, and you can easily just solve because then you just have X, Y, and Z in this case, and you're done. It's that easy. And that is the Gauss Jordan method. And we're going to introduce that in the next video.